Hello students, in this video we'll discuss about heap management and garbage collection. So in the last video we have discussed the axing of non-local data on the stack and also the parameter passing. So what does it mean by heap management? First of all, see in stack the only function activation records will be allocated. In static the compile time. But where we should store all these dynamically allocated objects. So for that we are going to use heap memory. See in C language we are going to have dynamic memory allocation functions like malloc, right? So where this malloc memory will be occupied. It is not in stack because only for activation records, not in static because only for the compile time, but malloc means dynamic, right? So then we use the heap, and when the data must be in the heap in a perfect situation, if the memory is allocated and that is used by someone, then that must be in the heap memory. Otherwise, it must be deleted from the heap memory. Then how we have to manage it? See, generally we use the allocate and deallocate functions to allocate the memory into the heap or deallocate the memory from the heap. See, in C language, to allocate the memory, we use the malloc, memory allocation. So how much memory you want dynamically, we can call it by using the size of operator or directly specifying the memory how much you need, then we can allocate it. So once your task is done, then if you want to delete from the memory, then you can use a word called free. So by using the free and pointer, then we can deallocate or delete the memory from the heap, how much you have allocated with that pointer. See this sometimes we can call directly by the OS also. So how does this malloc or free work? See, so blocks of unused memory stored on a free list, and whenever you call it free, that can be removed. But see, malloc means first it will search for the free memory in the heap and the size how much you are allocating and the size how much is free continuously. If it is matching or if it is more the free, then the malloc allocate the memory. For example, malloc is expecting 20 bytes, but nowhere the 20 bytes of memory is free. You're having 10 bytes here and 10 bytes here and 5 bytes somewhere else. Continuously, if you are not having the 20 bytes, then this can't allocate the memory. But we are having somewhere here and here, which is more than the malloc. Then how we can utilize it means first you have to free the memory, then that will be stored in the free list. Then whenever the memory is deleted from the free list, then that can be allocated by using the malloc. So whenever you are calling malloc, first it will search for the free memory. If it is, then it will allocate. Free means first we are making sure that yes, this is unused memory and that can be deleted directly from the heap. Okay, then who is going to do it? And first of all, what is the drawbacks of heap management means malloc is not free, so you have to find the memory that is a cost, right? It costs something, and we are going to have some fragments. Leaving small unusable pieces may leads to, even though we are having the available space, but may leads to unallocating of memory to the malloc. Then we have to merge these blocks when freed. Then who is going to do all this? So memory management is always a cost. We want to minimize the cost, maximize the reliability. Then how can we do it? See, first, whenever the memory is allocated, we have to request them in a small size, and storage was repeatedly released, like first allocated and first deallocated, so that we can, what for example, if you are having a continuous memory, whichever is allocated first here 10 bytes, then 20 bytes, first the delocation should be done here, then done here, so that the memory will be continuously freed and that will be utilized quickly. Then what are the desirable properties of the memory management? First of all, space efficiency. So we should not have leftover, and program efficiency, so that we can quickly allocate the memory if it is free, and low overhead. To overcome this, right, when even though you have called the free memory, it is going to be in the free list, right? Then how can we make it? So for that, we are most of the programming languages are using garbage collection. Once the memory is unused, chunks wise, blocks wise, small pieces wise, then the garbage collector is going to identify all such unused memory and it is going to release that memory from the heap. So then data that cannot be referred generally is known as garbage, and most of the programming languages uses the automatic garbage collections. Sometimes we can call it, right, statically we can call the garbage collector. Then when we can say that a memory is useless, so as I told you, which is not referred by anyone, and some they have created and forgotten, they are not using it all, right, free for the long back. And some objects are created but they are not reachable to any other unreachable code. Then some objects are not reclaiming their space, so those are treated as garbage data. Then what is this garbage collector is going to recollect all such memory. But what are the goals for this automatic garbage? First you should know which type of data. See, assume that if it is an integer type, we have to free the continuously 4 bytes. If it is a float, continuously 8. Based on the type, we are going to identify the block, right? Then how to say that it is type safety? For example, guys, listen here. So you have stored an int data float with the 8 bytes, but you have not assigned. But this is pointed by someone, right? Pointed by someone. Now you are having, before that memory, we are having something which is unused and we found that it is a unreachable code. So we can collect this, but we cannot collect the next block. And we have an unused block here. We can also collect this. But how can I skip this? See, this was pointed by a pointer and with the float type. So we have to leave the 8 blocks, then we have to start from the 9th block. So this is called type safety. Then how can we occupy this? If it is a statically typed language, we can call it as static type safe. If it is dynamic type space, we can identify. So if it is not dynamically and statically, we can call it as unsafe. Sometimes we are going to delete it. So garbage collection, of course, it is expensive because we have to find so many things, and type safety, data unused, unreachable, right? So many things has to be done before collecting the data. What are the metrics we use? Overall execution time by collecting the garbage data. What could be the execution? If the garbage collection takes more time, it's useless, right? So space usage, by using the garbage collection, whether you are going to use less space or is it equal, then in that case also it is useless. Then pass time, when you are collecting the memory, how much time you are passing the original program or you are letting it to do some other task. That also depends on the garbage collection. And locality, program locality, where it is being executed. Then how this garbage collection is going to be done? We use two techniques, guys: reference counting and tree based. So what does it mean? Whenever an object is created and whenever a memory is organized, how many are accessed it? So we have to create a reference count. So if the memory is called by 2 or more places, like for example, you have declared a int variable and that is called by a number of blocks, a global variable. If it is used by 2 blocks, then we can say that reference count is 2. If it is called by only 1. If it is not used by any other, 0. So based on the reference count, you have to identify whether that block is used or unused. So if it is a 0 reference, no one is using, then that can be directly removed. And if it is greater than 0, right, then we can say that it is not garbage for that instance. But is actually garbage or not, then we will find it based on some other parameters like unreachable code, or no one is used at all, or no one is used for the long time, or the original program is actually terminated. So we have so many other criteria to identify even though the reference is greater than 0. Then the other way is tree. So for example, we have a function, then this function is calling this variable and that is function another variable calling another, like this, right? So from the main function, right, from the main function, and assume that every activation record is a root, a node, right? Every activation record is a node. Assume that. So from the main, what is the link established, right? So assume that main is calling another function like this, recursively calling. They are in live. So assume that the main is called one function, but after some time it is done. And this is calling another. So this is live because it is calling another and it is calling another. Recursively they are calling. But actually the link from the main function is already broken. So then we cannot collect this. So these chunks or blocks of code is called as dead. So then what you have to do, we have to call the functions and we have to create a tree of the activation records. If they are not reachable from the root node, then we can say that it is a dead. So such dead blocks code will be removed by the garbage collection. So there we are having some variations. Incremental garbage collection means we have to go one level by level, like first level, second level, incremental one, right? Like this. And the other one is incremental reachability collection, like from the root node whether they are reachable or not. And partial collection. So sometimes even though that is not reachable from the root, that has to be there for some other, right? We are establishing the link. And that is partial. And last one, general garbage collection, whatever we have used earlier. So this is about garbage collection. So in the next video we'll discuss about code generation and optimization, that is unit 5.